Okay, guys, this is the lesson today for solving quadratic equations, and the method that we're working on today is solve by factoring. So in order to be able to solve by factoring, you have to be able to factor. So this is what we've been working on last chapter. X squared plus 5x minus 24 is a quadratic that I can factor. So we start out with our x's. The minus sign tells me that the signs have to be different. And the numbers that multiply to 24 and subtract to 5 would be 8 and 3. 8 goes with the plus because the 5 is plus, and 3 goes with the minus. 2x, we have a leading coefficient. Let's see, does it factor out? Oh, 11 doesn't divide by 2, so nope. So we have to think of all of our factors that multiply to 2 times 12 is 24. So 1 times 24, 2 times 12, 3 times 8, 4 times 6, and they have to add to 11. So that's 3 times 8. So we start off with both of these having two x's and an 8 and a 3. The signs are the same because the plus sign, and they're both minus because that's a minus. And then we're looking for which of these factor, maybe both of them do. 2 and 8 both divide by 2, so I can take a 2 out. And I'm left with something here. Where is it? I am left with x minus 4 and then the other one does not factor, 2x minus 3. Okay, we got a vocabulary word here. It is roots, and the roots of a quadratic equation are the x values of the zeros, which are the x-intercepts of the graph. So if you notice, we got a 0 right here at 0, negative 8. Excuse me, negative 8, 0. I said it backwards. And we have another one over here at 3, 0. Okay. Now, this graph goes with this quadratic right here. So we got this 0 right here and this 0 right here. And roots are the x values, so the 3 and the negative 8. And what do you notice? That's a plus 8, that's a minus 8. Same number, different signs. Okay, just like chapter 11. Same number, different signs. So this is factored form, this is the zeros. Over here, I've got a 0 right here and a 0 right here. This one's at the root is 1, 2, 3, 4. The root is 4. And I see a 4 right here. This one I see a 0 halfway in between 1 and 2. And so it'll relate back to this, as you'll see later in the lesson. Okay, we got to talk about something called the zero product property, because this is the crux of how we solve a quadratic equation by factoring. Zero product property, you learned this when you were in 3rd grade and did your times tables. Anything multiplied by 0 is 0. So 0 times 5, 0. 0 times anything is 0. Even if it's a distribute, okay? If I do 0 times x and 0 times 2, 0, 0, all zeros. Now, I don't see a 0 here, except that 3 minus 3 is 0. And then we're back to something that looks like this, 0. And this is what relates to what we're doing. So if this were, what we're going to do today is this number here would be an x. And we're going to figure out that 3 is what should go here, because my goal is to make something multiply to 0. So if I put a 3 here, 3 minus 3 is 0, and 0 times anything is 0. Okay? So, how do you solve a quadratic equation? All right. first we have to set it equal to 0. That means that there should be an equals 0 after our quadratic. It might not be set up that way to start with. We're going to have to make it be that way. Once we have it set equal to 0, then we're going to factor it. Then we're going to take each factor and set it equal to 0, and then we're going to solve for the variable twice, because most quadratics have up to 2 solutions. Okay, this is the examples from your page 746 in your book. So we start, here's our quadratic. Now the first thing on my bulleted notes on the previous page said set the quadratic equal to 0. This is already equal to 0, so we can move right on to factoring. So if we factor, we get x minus 6 and x minus 2. Signs have to be the same. They both have to be minus, and 6 and 2 work. Now what I want is to figure out what numbers could make each of these factors a 0. So I'm going to take each one and how am I typing state? So I'm going to take x minus 6 equals 0. Okay, so what minus 6 would equal 0? Well, a positive 6 minus a negative 6. Okay, and if we come over, that's one of our solutions, and if we come over here and look at the graph, the parabola crosses at positive 6. So the root of the parabola at 6 is the solution. So a graph is a good way to check. If I got x equals positive 6 and I put my quadratic in my y equals, and I see that it crosses at positive 6, I did it right. And my other factor was x minus 2, and we set that equal to 0. Well, what take away 2 would be 0? 2. And the graph crosses at positive 2. Let's practice that one more time. Here's our next quadratic. Again, it's already equal to 0, so all we have to do is factor it. All right, x minus 8 and x plus 3 equals 0. Then take each factor. X minus 8 equals 0. Well, what take away 8 would equal 0? Positive 8. And that's a solution over here on the graph. Okay. Then we'll take x plus 3. What plus 3 would equal 0? Well, in order to cancel out a plus 3 and make it a 0, we would need a minus 3. Okay. So these are the solutions. These are the answers to this quadratic. Okay, on this page, this problem, skipping right to 6 here, we've got a slight difference. We've got x squared minus 11x, but there's no b, or there's no c term. So in this case, we're not going to factor it as two binomials. We're going to factor out an x. We're going to factor out an x to the outside. If I factor out an x, then in the parentheses, I'm left with x, 1x left, minus that x got factored out, so minus 11. Okay? So if you have an x only on the outside, reverse distributive property, then we kind of think back to this situation right here. If this is a 0 right here, then it forces the answer to be 0, no matter what's in the parentheses. So if this x were 0, then it wouldn't matter what's in the parentheses. The answer would be 0, which is what we want. So one of my solutions is x equals 0. So just remember, if you have an x just by itself outside, even if it had a coefficient, x on the outside would make 0 a solution. Then we're going to have x minus 11 as our other factor. And what take away 11 would be 0? Well, a positive 11. And we can see that on the graph, 0 and 11. Okay, so 7 and 8 are situations where if I look at my equal sign, there's not a 0 here. It's a minus 7. And I want it to say equals 0. So to get the 7 to the other side, okay, think of it kind of like we have a negative, the equal sign is the battle line, and -7 is on this side of the battle. But he's going to change his mind, so he's going to change his sign. All right, so +7, +7, that gets him to the other side. Change his mind, change his sign. And so this side would cancel out, and I would get a 0 here, which is what I want. Now, 8x and 7 can't combine because they're not like terms, so we just write it out as a quadratic. X squared plus 8x plus 7 equals 0. And then we factor that. Okay? Now, some of you are able to say in your head, okay, so what value for x here plus 7 would make a 0? Where are you? Okay, that would be -7. So a -7 and a +7 would zero out that factor, and we would get a 0 answer. Also, a -1 here would zero out that factor and give me a 0. And on the graph, I can see -1 and -7 are my roots. Okay, so I had to move the -7 to the other side of the equal sign, change his mind, change the sign. All right, number 8 is a toughie. Because I've got two terms over here that after the equal sign, I've got two things I got to move over. So 13x is going to be -13x, and -81 is going to be +81. And we can move those over at the same time. So change the mind, change the sign, and we're going to do the same thing on this side of the equals. So x squared doesn't have any like terms. It's going to come down. But I didn't line this up. It doesn't fit very well to line them up together. So -13 and -5x, those are like terms. I spent 5, I spent 13, so I spent 18. And then +81 just comes down. And because my whole goal was to make those 0 out, my equation is now equal to 0. I can factor this, and this factors in our special way of x minus 9 and x minus 9 equaling 0. They're both the same. So if they're both the same, I could put 9, a positive 9, in either spot for x and get a 0. So I don't have to write the 9 twice. And in fact, let's look at the graph. You can see the vertex of the graph sits on the 9. The parabola touches the x-axis one time, and it's on the 9. The root is 9. Okay, so that's kind of special. Many of our parabolas are going to cross the x-axis 2 times. Sometimes the vertex sits on the axis, and that's one solution. And then later on in this chapter, we'll talk about, well, what happens when the parabola doesn't touch the x-axis at all? Okay, but we're not quite there yet. Okay, so number 10 in your book does not, has a leading coefficient, but it is already set equal to 0. So that's one thing. But we're going to have to do our 8 times 21 is 168. And this factor list ends up being kind of long, but remember we have our trick in our calculator, y equals 168 over x, and we can get the whole factor list from the calculator. Okay, and it turns out 12 and 14 are the ones we're looking for because we want something that multiplies to 168 but subtracts to 2. So I've got 8x for both. The minus means the signs are different. And okay, the 14 goes to the plus because the 2 is plus and the 12 is minus. All right, then we got to start factoring, and this one factors a lot. All right, 8 and 14 both divide by 2. Okay, and that leaves us with 4x plus 7. Then 8x minus 12, okay, they both divide by 4, okay, and you have to do the 4. You can't say, well, they also divide by 2. Well, that's true, but you have to factor them as much as possible. So otherwise this doesn't work. So then I've got 2x minus 3 equaling 0. Now, both of these factors have coefficients, so I have to set both of them up as basic two-step equations. 4x plus 7 has to equal 0, and 2x plus 3 has to equal 0. So we'll solve this one first. If that's a plus 7, we'll do minus 7 both sides. So that cancels out. And bring 4x down. And so 0 take away 7 is negative 7. Then divide both sides by 4. And x equals negative 1.75. And we can see that on the graph right over here, negative 1.75. Then we've got to factor this one over here. So add 3 to both sides and get 2x equals 0 plus 3 is 3. Divide by 2 on both sides, and x equals 1.5. Okay, you could leave it as 3 halves as you want, but the decimal is kind of easier to see on the graph. Okay, didn't realize I was recording there, so I apologize. I thought I hit pause. All right, so this is difference of 2 perfect squares. So I've got 3x and 3x and 5 and 5. So those are the square roots of each term. Difference means subtracts 2 perfect squares. Okay, so the signs are different, but the numbers and the coefficients are the same. So regardless, now that it's factored, I do everything the same way that I have been. I'm going to take each factor and set them equal to 0. Okay, so here I'm going to subtract 5 on both sides. Okay, and I'm going to get 3x equaling a negative 5. Then I'm going to divide both sides by 3. And x equals negative 1.6. Over here, I'm adding 5 to both sides. So 3x is going to equal a positive 5. Then I'm going to divide by 3 both sides. This looks exactly the same, doesn't it? Except that's a negative and that's a positive. So I get a negative 1.6 and a positive 1.6. That means my solutions are the same. They're just opposite signs. And that's a special thing that happens in 2 difference of perfect squares. Okay? Now, here's a homework one. This one is special because we have a negative sign out here in front. And you guys are getting this exclusively as YouTube channel viewers. I did not go over this in class. So number 4 on the homework has a negative sign out in front. Well, factor out the negative, okay? So that means x squared plus 4x minus 12 equals 0. And that's a legal move because it doesn't change how the graph crosses the x-axis. Remember, with the negative sign, all that leading negative sign does is flip the parabola over. Okay, so if there was no negative sign here, the parabola would be exactly the same except that it would open up. So I'm still going to take what's inside and factor it. So carry down the negative, okay? Minus signs are different. Plus sign means the 6 goes to the plus. 6 times 2 makes 12. 6 minus 2 makes 4. And my solutions are -6 and 2. Okay, remember, the negative sign does not influence my solutions. Okay, the negative sign does not affect the solution. It just flips the parabola to open down. The solutions would still be -6 and +2 if we put that quadratic in instead. It would just be a quadratic up, facing the other way. So again, you only get this homework question if you watch the YouTube video. All right, this is the end of the video. Good luck. Remember, your 12-4 packet is due on Thursday. Have a good day.